In this video, I'm going to talk about equivalent resistance. In the previous video, when I was talking about Ohm's law, we solved problems with one resistor and one battery. What if we have multiple resistors in a circuit? How do you find the total resistance? If you have two resistors, let's say a 5 ohm resistor and a 10 ohm resistor, there are two ways you can connect them across the battery. So this is the battery. You can connect them back to back. This is 5 ohm, this is 10 ohm. Or it's the battery, this is the first resistor, the second resistor, 5 ohm, 10 ohm, 50 volt battery. Okay, this type of connection is called a series connection. And this type of connection is called parallel connection. All the components are the same, just the type of connection is different. But if you're finding the value of the current flowing through the circuit, you'll get different values. Okay, so this is the equation to find current using Ohm's law. I equals V by R. But in this case, we have multiple resistors. I equals V over Req, where Req is the total resistance, or let's call it equivalent resistance. How do we find equivalent resistance? For series circuits, the equation to find equivalent resistance is Req equals R1 plus R2 plus etc. up to Rn for n number of resistors. For a parallel circuit, the equation is 1 over Req equals 1 over R1 plus 1 over R2 plus etc. plus 1 over Rn for n number of resistors. Let's solve some problems. We have three resistors, 5 ohm, 10 ohm and 20 ohm resistor connected in series with 70 volt. You can see they're connected back to back, right? So this is a series circuit. And the equation to find equivalent resistance of a series circuit is R1 plus R2. We have three resistors here, so R1 plus R2 plus R3. Req equals 5 plus 10 plus 20, 35 volt. Another question. We have four resistors in the circuit, 1 ohm resistor, 2 ohm resistor, 1.5 ohm and 4.5 ohm. Let's call them R1, R2, R3 and R4. R1, R2, R3 and R4. It looks like a parallel circuit, but it's actually a series circuit. I'm going to redraw the circuit. We have a battery. From this terminal of the battery, a 1 ohm resistor is connected. That's my 1 ohm resistor. From this end of the 1 ohm resistor, a 2 ohm resistor is connected. So this end of 1 ohm resistor, a 2 ohm resistor is connected. From this end, a 1.5 ohm resistor is connected, right? This end is connected to 1.5 ohm resistor. That's my 1.5 ohm resistor. And this end of the 1.5 ohm resistor is connected to a 4.5 ohm resistor. A 4.5 ohm resistor. This end of the 4.5 ohm resistor is connected to the negative terminal of the battery. This is the new circuit. In fact, these two are the same. This is a series circuit, right? The equation for equivalent resistance of a series circuit is R1 plus R2 plus, we have four resistors, so plus R3 plus R4. Req equals 1 plus 2 plus 1.5 plus 4.5, 9 ohms. That's the equivalent resistance of the circuit. Now, we're going to find the current flowing through the battery, the total current in the circuit. Let's call it I. Equation for I using Ohm's law, I equals V by Req. Voltage is 9 volt. Req is 9. 1 ohms. 1 ohms current is flowing through the circuit. Another question. We have two resistors in this problem, a 10 ohm resistor and a 30 ohm resistor. They're connected across a 77 volts battery. Let's call this resistor R1 and this one R2. I'm going to redraw the circuit. That's my 10 ohm resistor. It's connected to a 77 volt battery. We have R1, that's R1. That is 30 ohms. R1. So R2. These two are same. All right. This end of 30 ohm resistor is connected directly to 77 volt battery. This end is connected directly to 77 volt battery. Same for R2. This end is connected to a positive terminal of the battery, and this end is connected to the negative terminal of the battery. They're connected to each other as well. Okay, this is a parallel circuit. They're not connected back to back, right? In fact, they're connected directly to the battery. Okay, so it's a parallel circuit. And the equation to find the equivalent resistance of a parallel circuit is 1 by Req equals 1 by R1 plus 1 by R2. We have only two resistors, right? Yeah. Okay, let's solve it. 1 over Req equals 1 over R1 is 30 and R2 is 10. 1 over 30 plus 1 over 10. Solve it. 30, you can use the calculator. 4 by 30. 1 over Req is equal to 4 over 30. So how do you find Req? We need to find the inverse, right? So Req over 1 equals, we need to flip the right hand side as well. 30 over 4. 7.5 ohms. What's the meaning of this answer? Req equals 7.5 ohms. We can replace these two resistors with a single 7.5 ohm resistor. This is our new circuit. Replacing R1 and R2 with a single resistor Req. That is 7.5 ohms. And these two circuits are equal. Okay, now we have a 77 volt battery and a 7.5 ohm resistor. How do you find the current? I equals V by Req. I equals 77 over 7.5, 10.26 ohms. 10.26 ampere of current is flowing through the circuit. Another question. We have a 1000 volt battery and 3 resistors. They're connected in parallel, right? We can redraw the circuit like this. 1000 volt. 200 ohms. 100 ohms. 600 ohms. They're equal. They're the same, right? Okay. Now these three resistors are connected in parallel. Let's call them R1, R2, and R3. Equation for equivalent resistance of a parallel circuit is 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. 1 over Req equals 1 over 200 plus 1 over 100 plus 1 over 600. 1 over Req equals, you can use the calculator, 3 plus 6 plus 1. 10 by 600 or 1 by 60. Again, this is 1 over Req. We need Req, so flip it. 60 over 1 or 60 ohms. Equivalent resistance of this parallel circuit is 60 ohms. Or we can replace all the three resistors with a single 60 ohm resistor and the circuit behaves the same. I'm replacing, so we have a 1000 volt battery. I'm replacing all the three resistors with a single 60 ohm resistor, and they are equal. Now we need to find the current through the circuit, right? I. Equation using Ohm's law. Equation for current using Ohm's law. I equals V over Req. Voltage is 1000. Req is 60. 16.67 amps.